Okay, I need everybody to go ahead and get out 2 highlighters, and then I also need you to go out and get this worksheet, this notes packet that's in your binder from last class. So go ahead and pause this video until everybody is situated and you have this notes packet in front of you, as well as your 2 highlighters. Last class, we started talking about systems of linear equations. A system of linear equations is when I have 2 equations in a problem, like these ones down here, and I want to determine my x value and my y value. So the first thing we did was we just practiced checking our work. We practiced plugging in ordered pairs and seeing if they were solutions, and we would say yes or no. In order for something to be a solution, it had to satisfy the top equation and the bottom equation. So that's what we did last class. So go ahead and flip your paper. We then started talking about the 3 different methods to solve equations. The 3 different methods, you can graph, which is what we've been focusing on, or there's 2 other algebraic methods in which we can find the solution. So remember, my solution is where it's where I want to find my numerical answer for x and my numerical answer for y. When we graph it, where's my answer? Well, my answer is usually where my lines intersect. So last class we left this section blank. So that's cool because we're going to come back to that here in a couple of minutes. But I want you to go ahead and go to the next page so we can practice a couple more problems. Alright, so if we take a look at this, notice it says when we graph linear equations, we have 3 potential solutions. So when I'm graphing lines and I want to determine the solution is where? Well, it's where they intersect. So if you look at this example right here, how many times do your lines intersect? Well, they intersect once. They intersect right here. So that means on this problem I have 1 solution. So I'm going to write my answer as an ordered pair. The next one, take a look at it. My solution is where the lines intersect. What do you notice about those lines? Well, hopefully you notice that those lines are parallel. Are those lines ever going to intersect? No. So, what kind of solution would I have here if they're never going to intersect? Well, I'm going to have no solution. My lines are parallel. Now, parallel means they're never going to meet. So there's no way that these lines are ever going to meet. No matter what, if I extend them forever and forever and forever, all the way off this page, they're never going to intersect. Now, notice if I draw something like this. Right now, are these 2 lines up here intersecting? Well, no. But if I ever extend the arrows, are they going to intersect? Absolutely. So you have to be really, really careful that you're not going to intersect, that you're not going to tell me that a picture like this would mean there's no solution. If you ever get a picture like this on a graph, that probably means you messed up. Look at the last one. The last one, my 2 lines are stacked on top of each other. So my 2 lines are stacked on top of each other. How many times do they intersect? Well, they intersect everywhere. So this is where I would write infinite solutions. My lines are stacked on top of each other. So there's only 3 potential answers you can have. You can have 1 solution where there's an ordered pair, 1 value for x and 1 value for y. You can have no solution, which is when your lines are parallel. Or you can have an infinite number of solutions, which is when your lines are stacked on top of each other and they produce the exact same line. So I want you to go ahead and flip this paper back over. You should have problems 8, 9, and 10 left to graph. So I want you to graph 8, 9, and 10. And then I want you to check your answers with your elbow partner. When you're good to go, I want you to flip all the way to the very back page. So I want everybody to look at number 6. Let's go ahead and graph number 6. We're going to do this one together. We're going to skip 4, just because I know it's not a good problem. So I'm going to highlight my top equation. So looking at that equation, can I immediately graph? No, because y is not by itself. So in ways that I can become organized is by, instead of cramming all my work in this teeny amount of space, I'm just going to come up over here and I'm going to rewrite it. Y plus, oh, excuse me, it's 4x plus y. 4x plus y equals 4. I'm going to subtract 4x on both sides. So I have y equals negative 4x plus 4. So m equals negative 4 over 1. B equals 4. So 1, 2, 3, 4. 1, 2, and then go down 4 over 1. Although I'm going in the wrong direction because it's negative. Down 4 over 1. Down 4 over 1. Connect my dots if I can make that look slightly presentable. Okay. So now I'm going to highlight my second equation. And I think I'm going to have a typo in this question. Okay, so this problem, there's a typo. So one thing we need to change is I want to change that 6 to a 2. Otherwise, it's not going to work. So I'm going to change that 6 to a 2. So go ahead and change that 6 in my blue equation to a 2. And let's see if that's going to work out. So I'm going to erase my work from my previous question if it'll allow me. Just kidding, it won't allow me. Perfect. So I'm just going to come over on top over here and I'm going to write. So I have 2x minus 2y equals 2. So can I immediately graph? No. Why? Because x is not alone. So what am I going to do first? I'm going to subtract 2x on both sides. So I have negative 2y equals negative 2x plus 2. What am I going to do now? I'm going to divide everybody by negative 2. So y equals x minus 1. So m equals 1 over 1. B equals negative 1. So plot negative 1. Go up 1 over 1. I know I got it right because my points overlap. Up 1 over 1, up 1 over 1, up 1 over 1. Because my points already overlap, I don't have to go all the way across my grid unless you want to. So there's my line. So where's my answer? My answer is where they intersect. So my ordered pair is 1, 0. Hopefully you're all doing okay. So I now want you to pause this video and I want everybody to attempt number 7. And when you get stumped or when you find something interesting, I want you to pause and then when we're all on the same page, we'll bring it back together and we'll talk about it. So you should have had no problem graphing this top equation. So I'm going to go ahead and graph that real quick. All right, so my top equation's graphed. So now let me look at my bottom equation. Can I immediately graph it? No, I got to get y by itself. So I'm going to add 3 on both sides. So y equals 2x plus 3. So 1, 2, 3. Go up 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. So what do you notice? Notice it's the exact same line when I plot it. So when you're graphing two equations on a coordinate plane, what are you looking for? Well, you're looking for where the lines intersect. Where do these lines intersect? They intersect everywhere. They don't just intersect on these 6 points. They keep going and they keep intersecting forever. So, if they intersect forever, how many intersection points are there? There's infinite. So when my lines are the exact same identical line, I'm not going to sit there and write every ordered pair out there that works. I'm going to write infinite solutions. So when my lines overlap each other, and they form the exact same line, they intersect everywhere, which means I have infinite solutions. So I want you to go ahead and flip back on the other side of your paper, that section in the middle that we left blank previously, and I want to talk about it. So everybody should be good with graphing. So have you noticed that the graphing method is the easiest method to mess up on? It's super easy to make careless mistakes. You actually make a negative slope instead of a positive slope and vice versa. It's not that it's hard, it's just really easy to make mistakes. Would you agree? So there's better ways to do this. So a better way is an algebraic way. So the first method is what's called the substitution method. The substitution method is a nicer way, so instead of having to get y by itself, find m, find b, plot my points, I can literally just solve this by solving an equation. So, when you hear the word substitute, what do you think? Well, a lot of you think you hear the word substitute when it comes to a substitute teacher. So what's the role of a substitute teacher? Well, the substitute teacher is to fill in for Miss Mayfield when she's not there. So, substitute in math is the exact same thing. What do you think? It's to fill in. It's another thing for substitute. Well, to replace, or maybe to exchange. All of these words are great words that represent substitute. So we have a goal. My goal, find the numeric answer for x and y. So my goal obviously is the same. I want to give an equation with an x and a y in it, and I want to be able to find the numeric answer for x and the numeric answer for y. So we have steps to help solve these problems, and when we write these steps down, they're going to sound like I'm speaking a foreign language, and I just want you to write them down, and then we're going to talk about them. So let's do this together. Step 1, highlight the equation that has a positive variable without a coefficient. That's step 1. Highlight the equation that has a positive variable without a coefficient. So on these problems, you always have two equations. So you're choosing either the first one or the second one, and you're going to highlight that equation that has a positive variable without a coefficient. Step 2, take that equation and solve for that variable. So I'm going to take the equation that I highlighted, and I'm going to get whatever variable was positive without a coefficient by itself. That's what step 2 tells me to do. Step 3 needs a star. Step 3 is the hardest part. If you can do step 3, you are golden. Step 3, take answer from step 2 and plug it in to the other equation. Then solve. I'm going to take the answer from step 2, plug it into the other equation, and then I'm going to solve. That's the hardest part. I'm taking my answer from step 2, and I'm plugging it into the other equation, and then I'm solving. Step 4, take answer to find other variable by plugging answer into one of the given equations. So go ahead and pause this video to make sure everybody got this all copied down, and then we're going to see what this hieroglyphic madness sounds like. Alright, so let's take a look. And my pen is really fabulous. As you can tell, my handwriting is just phenomenal here. So I'm going to take up a lot of space, but I want you to try to keep everything confined in the boxes. So we're going to focus on this first problem. So notice it's my first step. Highlight the equation that has a positive variable without a coefficient. So I have two equations. I have this top equation and I have this bottom equation, the first one and the second one. So which equation has a variable that's positive and doesn't have a coefficient? Well, that's the first one. So I'm highlighting this first equation. So out of that first equation, what variable is positive without a coefficient? Well, x is. So I'm going to come over here and I'm going to rewrite this equation. X plus 2y equals 4. And step 2 says I'm going to take that equation and solve for that variable. So what variable was positive without a coefficient? X. So I want to get x by itself here. So what am I going to do to get x by itself? Well, I'm going to subtract 2y on both sides. So I have x equals negative 2y plus 4. Or 4 minus 2y. Order doesn't matter. So I want you to go ahead and I want you to circle this. And once you circle this, I want you to lightly put a line through that equation you highlighted because you're not going to use that equation again. Is everybody with me? All right, here comes the hardest part. Step 3. Take my answer from step 2, which is this, and plug it into the other equation. So my answer is negative 2y plus 4. So every time I see an x, it means the exact same thing as negative 2y plus 4 because that's what equals mean. So I'm going to take my answer, and every time I see an x in my bottom equation, I'm going to open up a parenthesis, and I'm going to substitute negative 2y plus 4. So every time I see negative, and whenever I see an x in this equation, I'm going to open up parentheses and plug in negative 2y plus 4. So I'm going to write down everything I see. So I see a 2. Oop, I see an x. Open parentheses, drop in negative 2y plus 4. I see a minus sign. I see a y. I see an equal. I see an 8. I'm taking this equation, and every time I see an x, I'm plugging in my answer, which I found. So now all I'm going to do is solve. So, friends, how do we solve? Distribute first. So I have negative 4y plus 8 minus y equals 8. What am I going to do now? Well, I'm going to combine like terms. Draw your slashes if you have to. I have negative 5y plus 8 equals 8. What am I going to do now? Subtract 8 on both sides. So I have negative 5y equals 0. Now I'm going to divide by negative 5 on both sides. So what's y equal? Well, y equals 0 because 0 divided by negative 5 is just 0. So I found my numerical answer for y. What is it? It's 0. Awesome. So now what am I going to do to find x? Let's look at step 4. Take my answer from the other. Find your answer to the other variable by plugging my answer into one of the given equations. So these equations up here are one of my given equations. So I'm going to take y equals 0, and I'm going to just plug it into the first one. And every time I see a y, I'm going to plug in 0. So x plus 2 times 0 equals 4. 2 times 0 is 0, so this just goes away. So what's x equal? Well, it equals 4. So I'm going to write my answer as an ordered pair. So is it 0, 4, or 4, 0? 4, 0. and I'm done. So, if I had have taken these two equations and graphed them on a coordinate plane, I would get 4, 0 is where they intersect. If I don't have a coordinate plane, I can use the substitution method. Hopefully you're all doing a little bit okay. Don't stress out because we're getting ready to do the next one. Alright, so let's go ahead and look at the next problem. So, step 1. Highlight the equation that has a positive variable without a coefficient. So which equation has a positive variable without a coefficient? Well, the first one does, and the second one does. In this first equation, which variable is positive without a coefficient? X. How about the bottom one? Y. So it really doesn't matter which one you use because you're going to get the same answer. So I'm just going to use the top equation again. If I highlighted the bottom equation and solve for y, I'm going to get the exact same thing. So step 2. Take that equation and solve for that variable. So, take this, x minus y equals 6. What variable am I solving for? X. How do I get x alone? I'm going to add y to both sides. So I have x equals 6 plus y. I'm going to circle this so I see it, and I'm going to cross out that equation that I highlighted. Step 3, take my answer, which is 6 plus y, and every time I see an x in my second equation, substitute it in. So I'm going to take this equation, and every time I see an x, I'm going to plug in parentheses 6 plus y. So I see a 2, I see an x, open parentheses, drop in x plus y. I see a plus, I see a y, I see an equals, I see a 0. So now what am I going to do? I'm going to solve. So what's the first thing I'm going to do to solve? Distribute. So I have 12 plus 2y plus y equals 0. I'm now going to draw my slashes and combine like terms. I have 12 plus 3y equals 0. Subtract 12 on both sides. So I have 3y equals negative 12. Divide by 3. So y, come up here, y equals negative 4. So I found y. What do I have to do now? I have to find x. How am I going to find x? I'm going to take my answer, y equals negative 4, and I'm going to plug this into any one of the typed equations. And the reason why I plug it into this one or I plug it into this one is so in case I made a mistake somewhere else down the road. So I'm going to plug in negative 4 into this top equation. And I'll write in a different color so you can see it. So I have x minus y, which is negative 4, equals 6. So I have x plus 4 equals 6. So subtract 4 on both sides. I have x equals 2. So how do I write my answer? Well, I write it as an ordered pair. So if I come up here, my ordered pair is 2, negative 4. And I'm done. Alright, let's look at the next one. I want you to pause this video and I want you to take a couple minutes and attempt this on your own. Just attempt number 3, and then we'll unpause this video and we'll kind of go through it together. So, step 1. Highlight the equation that has a variable that's positive without a coefficient. Which equation is that? That's the second one. Let me not write in pen, let me write in highlighter. So, I'm going to take that equation and solve for y. I'm going to write in blue so you can kind of see the difference between example 1 and example 3 because I can't erase it. So I have 4x plus y equals 24. So what variable am I solving for? Y. How do I get y alone? Subtract 4x on both sides. So I have y equals 24 minus 4x. Circle. So okay, from here, what do? Every time I see a y in this other equation, substitute in 24 minus 4x. So 2x minus 3, I see a y, open parentheses, 24 minus 4x equals negative 2. Alright, so now solve. So I'm going to distribute 24 times 3. 24, negative 3 times 24 is negative 72 plus 12x equals negative 2. Now I'm going to draw my slashes. Combine like terms. 2x and 12x make 14x minus 72 equals negative 2. So I'm now going to add 72 to the other side. I get 14x equals 70. Divide by 14. X equals 5. So now that I found 5, x is 5, how do I find y? Well, I can plug it in. You can plug it into this one. You can plug it into this one. Hopefully you've noticed a shortcut. If I plug it into this one, it's going to be super quick. So I'm going to plug it into that one. So y equals 24 minus 4 times 5. Y equals 24 minus 20. So y equals 4. It does not matter which one of these you plug them into. No matter what, when you plug 5 in for x into any one of these equations, you're always going to get y equals 4. If I write my answer like this, I'm losing a point. How come? Well, I didn't write my answer as an ordered pair. So my ordered pair will be 5, 4. So what does this ordered pair represent? It represents where these two lines intersect. They meet at 5, 4 on the coordinate plane. So go ahead, pause this video, and I want you to attempt number 4. Then unpause the video and we'll go over it. So if we do this last one together, highlight the bottom equation, y, because it has a positive variable without a coefficient. So I'm going to come over here and write x minus y equals 1. What variable am I solving for? X. I'm going to add y on both sides. So I have x equals 1 plus y. If this pen works. All right. Now what am I going to do? I'm going to take 1 plus y, and every time I see an x in that other equation, I'm going to plug it in. So 2, I see an x. 1 plus y minus y equals 5. So now, solve. Distribute. 2 plus 2y minus y equals 5. What am I going to do now? Draw my slashes. Combine like terms. 2y and negative y make y plus 2 equals 5. So now what am I going to do to get x alone? To get y alone? Well, I'm going to subtract 2 on both sides. So y equals 3. 50% of the way done. How do I find x? Well, take y and plug it in. I'm going to plug it into this one. X equals 1 plus y. X equals 1 plus 3. X equals 4. So, my ordered pair is 4, 3.